right, we'll go ahead and get started. Thank you so much for joining our Firewall Troubleshooting webinar. No matter where you are in the world, good morning, good afternoon, good evening. My name is Eden, and I am on the marketing team at Sunset Learning. And with me, I have Lars Meyer. He's the technical director at Consigas and has been working exclusively with Palo Alto Network Solutions for more than 13 years, both as a solution architect and an instructor. So he brings a lot of wealth of real life experience and best practices with him into the classroom and into this webinar. So we are very happy to have him here today and excited that you get to learn from him. A few housekeeping notes before we get started. Please post all of your questions in the Q&A tab as opposed to the chat. In the Q&A, we will be going over those questions at the end. So you can post them throughout the webinar, but just know that we will be answering all questions at the end of the webinar. So I think that's all I have for you. So Lars, you want to get started?
All right. Thank you, Eden. Good. So hello, everyone, and welcome to our session today. It's going to be a nice one. Prepared a couple of cool things for you. So what do we want to do today? So first of all, while this is a free training workshop, the most important thing for us here is that we want to show you the real thing. We want you to, after this hour, go out with some real learning. Okay, so we're not going to bore you just with some marketing fluff, but we want to show you the real thing. Okay, so and what we want to do is kind of introduce you to this Edu 330 firewall troubleshooting course. So why firewall troubleshooting? Okay, I believe it is one of the most insightful trainings that there is for Palo Alto Networks. Why? Because think about it, right? Most of you, I guess, are firewall administrators. And one of the realities of a firewall administrator is that, well, every problem is a firewall problem, right? And of course, 80% of the problems are in fact not firewall problems, but it's still up to you to prove it that it's not, okay? So, but what's the challenge, right? The challenge is for you to know for sure it is not the firewall, right? So while in most cases you're perfectly right, often it just needs one slip and then you're in trouble, right? We had this case with the customer. So this poor lad, he kind of firewall administrator, very seasoned, knew its stuff, right? There was a problem and he troubleshooted. He saw in the logs, right, traffic goes through the firewall, nothing is coming back. So he was convinced, listen, this is not a firewall problem, okay? So he told his boss, listen, not a firewall problem. There was kind of a lot of ping pong going back and forth for weeks with the application team, because the application team says it must be a firewall problem. And then after a couple of weeks, it turned out to be a firewall problem when we came in. So a very tricky one, a very interesting one, but it was one, okay? And of course now, right, the one time he was wrong, every time you're going to be remembered to, oh, you know, this other time where you were wrong, I'm sure it's a firewall problem, right? And from this moment onwards, you have a hard life because everything going to be a firewall problem and you cannot just push back. Good. So this is why I think firewall troubleshooting is so important, right? So because first of all, the next generation firewall is very powerful when it comes to troubleshooting. It gives you actually all the tools for you to know exactly what is going on. Okay, so and that's exactly what this firewall troubleshooting course is teaching. So what we're going to do today is the following, right? So we're going to start off with a little session where I actually just show you what is in this course. Okay, the entire instructor-led, full-blown classroom course. Okay, and then we're going to go behind the scenes, right? I'm going to show you the flow logic. What this is basically explaining what happens to a packet while it goes through the firewall, okay? We won't be able to go as deep as we can do in the course, right? But I think this will be still quite insightful, okay? Good. So, and then at the end, we leave some kind of time for some questions and answers, okay? Good. So with this, let's get started. So by the way, if you have any questions, just put it into the Q&A, and then at the end, we're going to get to it, okay? Good. So I'm going to go off camera now because I don't really think I want you to focus on the screen, right? My face isn't really adding any value here. So let's get started. Good. Okay. So first of all, let me tell you a bit more about this firewall troubleshooting course. Okay. So here we have not all courses, but a good overview of Palo Alto Networks training, right? So the firewall troubleshooting is this one here, the Edu 330. The reason I want to show you the slide is that there is an important prerequisite, which is this 802.10 Firewall Essentials Configuration Management. So to be honest, if you already have, let's say, a year's day-by-day practical experience with Palo Alto networks, perfectly, skip it, okay? Come straight into the troubleshooting course. Otherwise, make sure you take this one first, right? Because if you don't, then there's just, yeah, you're gonna be lost effectively, right? That's just so much, because in the firewall troubleshooting course, we're really gonna go deep into the firewall architecture, right? So the more you know about the next generation firewall beforehand, the better it is for you, okay? What other interesting courses are there? Well, there's Panorama. You might know Panorama. This is kind of the firewall manager, managing multiple firewalls. So this one teaches not only about how Panorama works, but also especially how to design a firewall network managing many, many firewalls, right? It's important because often what we see is customers starting with a few firewalls and Panorama, and at the very beginning it was just a few. It doesn't really matter how you organize it. But once you grow and you haven't built a proper structure from the beginning, it's going to be really messy to kind of clean it up afterwards, right? So that's why that one is important. So, and then actually one of my other favorite courses is actually here, Firewall Security Best Practice and Threat Prevention 802.14. That's a really good one as well, to basically learn how to harvest all of these cool next generation firewall capabilities to really secure a network, right? So, and then down here you see a bit of Prism Access, which is a special product in Codex XDR, and XOR for endpoint security and orchestration. Okay, good. Now, let's have a quick look at the agenda. So what is in this full course? So of course, the 803.30, it is a paid instructor-led course, okay? So, and what could you learn? It's a 3-day class, right? And we're gonna start with some tools and resources. The firewall has a lot of kind of powerful tools that you can use for troubleshooting, right? So here we basically just paint the scene to say, what are they? So then, very important, CLI primer. We're gonna go deep in the CLI. Has a lot of kind of cool tips and tricks that you can do via the CLI. Right now, by the way, firewall troubleshooting, right? It's not all about CLI, right? There is a lot of things from a troubleshooting point of view that you can do very well on the web UI, and other things you can do better over the CLI, right? It's actually all about knowing, right, what to do. I remember when I started playing a bit around with Cisco 20 years ago, it was, you were only a proper network engineer if you worked only on the CLI, right? Because GUIs at this time, they didn't really work, okay? This has changed kind of by a big leap, right? So now, again, what we always need to understand is what tool to use best, okay? But again, CLI, very nice. There's a lot of kind of tips and tricks you can see here to really kind of make this work. Good. So, and then we kind of dive into probably what is the most important element of this entire course, the flow logic. So a good piece of this module we're actually gonna talk about today, right? Well, and this is basically to explain what exactly happens to a packet while it passes through the firewall, okay? Because, why is this so important? It is important because once you understand how the firewall works, then there is a lot of things, a lot of information that it gives you, a lot of things where you might think, that's strange, why is it doing it like this, right? All of these things suddenly make sense, okay? So that's why this flow logic is so important. Good. Then we're gonna go to packet captures, right? Packet captures are an important tool for us to narrow down, right? Of course, with packet capture, classically, you can look at the packets, right, with Wireshark and see how they look like. But also from a troubleshooting point of view, it's important because, of course, what we are most interested in is actually dropped packet, right? Packet that the firewall drops and is not passing through, right? And let me actually show you here very quick in the lab, right? One thing that you can do when you do packet captures, right, is actually setting a stage, okay? So, and one of these stages is actually drop. So packet captures not only allow us to capture packets, right, but also actually to identify very particular packets, right, that the firewall is dropping. And then we can kind of zoom in and see what exactly happened to these packets, right? It's important because, there's a lot of traffic, and being able to pinpoint the exact packets, it's key, right? So, and then we kind of put these two things together, flow logic, understanding on how the firewall works with identifying the right packets, and then we go into packet diagnostics. What this is basically, it's logging effectively. It is logging that tells us what exactly happened to the packet at all these different stages go to firewall, right? So if a packet was dropped, why the heck was it dropped? Okay. Good. So then transient traffic, again, it's closely related, where we can have just some troubleshooting examples on how to troubleshoot traffic passing through the firewall. Okay. So, and then we have some other special topics from a troubleshooting point of view, which kind of go, first of all, into systems. So things like performance troubleshooting. That's actually one of the most tricky things to do, to actually troubleshoot the performance of a firewall, to if it runs slow, why it is running slow, right? So here we're gonna kind of talk about this one. Then some specific functions of the firewall. So IPsec VPNs, that's always a big one, right? Most firewalls, most internet-facing firewalls use IPsec VPNs, and knowing why they fail is always a key thing. So now we have SSL, right? Of course, SSL decryption these days, you cannot really do security without SSL decryption. But at the same time, SSL decryption likes to break things, not necessarily because the firewall is not doing it right, but more because of certificate chains being incomplete, some web server admins not having set up their server properly, right? There are so many different reasons why SSL actually can fail, right? And being able to pinpoint it is important, right? What I often see customers doing is just pinching a lot of holes into the firewall because they're just, oh, let's try to exclude this from SSL decryption. Oh, let's try to exclude this and let's see if it works, right? But see, this, by the way, is one important thing. Let's try this and see if it works. That's not really troubleshooting. That's trial and error, right? Real troubleshooting, what we're going to learn in this course, is really all about using the tools to see what exactly is happening. And then once we see what is happening, well, then we know what's exactly going wrong, and we don't have to do any guesswork. Okay, so again, troubleshooting is powerful, right? Because it takes the guesswork away. Good, and then next some other topics like user ID, right? Also global protect, remote access VPNs, and a bit of escalation in RMAs. Okay, so you can see there's a lot in there, right? Going really deep in the architecture of the firewall and seeing how this all works. Okay, good. Okay, by the way, with the class, of course, comes a lab as well, right? So how is the class run? It's a live instructor-led training, right? So you have an instructor like me or one of my colleagues, right, who kind of explains everything using slide, whiteboards, demoing, right? The majority of the course, to be honest, are demos where we really show you the real thing in the lab, right? And then you also can put the kind of the theory into practice with your own lab. So every student gets their own dedicated lab, right? And you can see it's, mimicking a real live network quite well, right? You have a client PC where you then access the firewall. You have kind of Linux server as well for some additional things with real internet access for kind of the different scenarios. You have a lab guide where you go through different scenarios, kind of using all of these troubleshooting tools in there. Okay. First of all, let's talk a little bit about kind of principles of troubleshooting, right? Often, what I think what is very important is that we kind of remind ourselves, what is the firewall actually meant to do? And what does it need to do these things, right? So of course, firewall is a security device. So, and at the same time, it's a network device. So you have packets passing through the box, right? So we have our firewall, right? And then we have basically packets passing through this box, right? And then the firewall is kind of inspecting them, okay? So that we kind of rethink this a little bit is really important, right? Because what we always need to understand is what kind of information does the firewall have to make its decision, right? Its decision is very simple, right? It has to say, is it good or bad traffic? Good packet, bad packet, right? That's essentially what it needs to do. But in order to come to this conclusion, that's very complex, right? And it can only do this based on real data, right? It cannot do any guesswork, right? So this is why when we kind of look at troubleshooting, we always need to understand, first of all, what is actually the data that the firewall sees, okay? So now, what I want to do here is kind of today kind of focus a little bit on a particular use case, like in the example that I kind of had at the beginning, okay? So imagine, you troubleshoot a problem, right? Internet isn't working, okay? And you don't actually see something in the logs, right? What does it mean? Does it mean that it is a firewall problem, or does it mean that it's somewhere else, right? In most cases, you probably would think must be something else, right? So, but the question is, how can you be sure if it's a firewall problem or not? Okay, so again, one of the important things I kind of want to answer today, right, in our session is, what are very common reasons why you actually see something not appearing in the logs? Let me show you an example, right? So here in our lab, so I open up a prompt, okay? So, and for instance, here I have access to the internet because I can ping 8888, okay? So that's working, nice. So at the same time, there's a problem because I'm pinging 1.1.1.1.1, and that's not working. Okay, so is it now a problem with 1.1.1? Well, if it is, then I probably should see something in the log where the packet leaves the firewall and nothing is coming back, right? So, and let's actually do this. So we go here into our logs, and let me just filter for the right packet, traffic. Let me actually also filter just for pings so we see this. Okay, so what we see is, okay, we do see the pings to 8888, they're working, well, that's good, but we don't see the ones to 1111. Why not? It's a bit of a weird one, right? Because, and then classically, what would people do at this stage? Okay, check the policy. Okay, we're going to check the policy, and then we see, yep, there's a rule that allows everything from the user's net to the internet, permit any, yep, this should work. Okay, now, of course, because we were able to ping 8888, internet access must be working as well, right? So, okay, must be a problem with the client, right? Or something else, right? Because if the packet doesn't arrive at the firewall, cannot be a firewall problem, okay? But here again, this is where we need to remind ourselves there can be various reasons why traffic does not appear in the traffic log. And there are actually good reasons for it, okay? So, and this is actually something we're gonna look at today, okay? Now, what else? Some other examples. I'm not sure, have you ever seen in your traffic logs when an application comes up as incomplete, right? So of course, we know applications as ping, Facebook, and stuff like this, but incomplete? Right? So what does this mean? Okay, so maybe to try to spoil this a little bit, right? What we can do, what is always a helpful thing for you to do when you troubleshoot is there's packets sent and received, right? These columns you always want to see, and here probably you already give half of the answer away, right? So in this case, right, we can see there was traffic sent, but nothing came back, okay? We're going to talk about this in a moment a bit more in detail, okay? So then we have not applicable. Okay, what does not applicable mean? Okay, so in this case, let's filter for not applicable. Right, so what we see is packet 421 and the application is not applicable. Why can it be not applicable, right? It's this next generation firewall to be paid so much money for. It's supposed to identify applications. So why is it not applicable? Okay. Good. And then kind of DNS traffic, interesting enough, we often see that it actually comes up as aged out, right? Should the session not always properly terminate, right? Like we see here where we have a TCP fin, but then here we see loads of traffic where it says aged out instead of TCP fin. Does it mean we have a problem in our network? Well, from a packet point of view, you see packet sent, packet received, so this looks okay, but why is this aged out? Okay. So, and the last one, the session ID being 0. Okay, so when we look in, let's say here on a packet, we can see a session ID. This often from a troubleshooting point of view is very important, right? There can be cases where this is actually 0. Okay, so why is this? Okay, so, and in order to answer this, let's actually jump to the whiteboard and let's get started to dive a little bit into the flow logic. The first flow logic we want to look at is this very simple one here. What I just want to point out here is kind of a typical session flow, right? So most traffic is TCP, Okay, so when we have TCP traffic, to start with, what do we see? Okay, so the very first packet, that's our SYN packet. Okay, so because here effectively what the client does is say, hey server, I would like to have a chat with you. Okay, and then the server comes back and sending back a SYN ACK. And with the SYN ACK, it's effectively saying, yeah, cool, let's have a chat. Okay, and then the final one is an acknowledgement, an ACK, right, where the client effectively says, hey, cool, yeah, we're gonna have a chat. Okay, so the important thing now here to realize is that these packets do not carry any application data. Okay, so previously we had this case where we said an application was not applicable or even incomplete. Okay, with this flow logic, we can actually already answer this question, right? So incomplete actually refers to the session. Okay, so when we have this three-way handshake, then we have a session established, right? And if this is not complete, so for instance, if we have only sent a SYN and a SYN ACK, but not seen the ACK, then the session was not fully established, means it's incomplete. Okay, so this means here, right, if we, let's say, we see only these packets at this stage, then we talk about incomplete. Okay, why is this important? Because already knowing this, when you troubleshoot your traffic logs and you see that a session to the destination IP of the application you're troubleshooting, you see a lot of incomplete sessions, right? It often can simply mean that, yeah, the server actually is not coming back, okay? And the session is not being established. So it gives you already a lot of information about what is actually going on here, okay? So now, then, very important, okay? If a packet gets dropped here, then actually then we would have a case where it's actually not applicable to identify the application. So this here is then our not applicable. So again, if the firewall would drop the packet at any of these stages, right, then our traffic would actually come up as application not applicable. Now, why is this? The reason behind this is that actually, so let's say we have a web session, SYN/ACK session is established. The next packet, when we have web traffic, for instance, would be an HTTP GET. Okay, so, and the important thing to realize here is that this is actually now the very first packet that includes application data. Let me actually show you this to you in our lab. Where's the lab? Here it is. Okay, so here I have a packet capture. Okay, and here we actually see, you know, the session setup. So as I told you, right, we have a SYN, TCP SYN, right, from the client to the server, right? So an important, when I look at the SYN, what do I see? Well, we see the MAC addresses, so that's our layer 2, right? We see our source and destination IP, so that's our layer 3. And we see our source and destination port, that's our layer 4. But that's it, nothing else, okay? There is no application data. So, and here comes already kind of the answer to the question, right? If the firewall doesn't see any application data, well, then it cannot identify the application, of course, right? So, and that's very important for us to actually realize that there are kind of stages in the lifetime of a session, right? For the SYN ACK and ACK, where there is no application data. And with this, the firewall simply has no way to identify the application. And of course, we don't want to do any guesswork, right? So, but then once we go see here, the HTTP GET, now we can see layer 2, layer 3, layer 4, and our HTTP packet. So now we see, okay, cool. This is web browsing. Okay, so now we can identify the application because now the packet does in fact include web details. Okay, so again, this is important. Okay, so this means that if the firewall drops a packet already at this early stage, right, then it will come up as not applicable. In the next one, I can actually kind of show you, we're going to go into this a little bit more in detail. Okay, I just want to kind of prime this discussion here a little bit. Okay, good. So let's go over to our next one. What I now want to do is go actually through the use case of what happens to a packet step by step while it goes through. Okay, one important thing that we have already seen now in this flow chart is we cannot only look at one packet we actually need to look at the session. Okay, so because there's always a lifetime of a session. Why is this important? Well, our next generation firewall first of all identifies application. We already now have learned that only at certain stages we have an application, right? So in this case here we have, for instance, web browsing. Okay, but very important as well, an application can actually change. What about, we kind of, send more packets. With this, the firewall receives more details. And now we actually see, hey, hang on, this is not only web browsing, this is actually, let's say, Facebook. Okay, so we can basically see more details, and based on the additional details, we can identify other applications, and with this effectively do what we call a shift in the application. Okay, good. So let's go forward here. Okay, so again, what we want to do now is go through the use case of one packet, or one flow goes through firewall, and what happens? What does the firewall do? So let's get started. First of all, what do we have, right? We have here a client, and let's say the client has the IP address 192.168.1.20. Okay, so and let's say here we have a web server, and let's say the web server's IP address is 20.3.3.1. Okay, good. So this means, here we have a packet, right? And this packet now arrives on the firewall. The first thing that we have to recognize is that we have different stages at which the firewall is inspecting the packet. Okay, where it does different things, looks at different elements of the packet. Okay, so the first stage is actually what we call our ingress stage. Okay, so ingress, okay, what does it mean? Well, we have here a layer 3 interface, okay, and our packet is coming in here. Okay, so let me go here, and let's say we have now here our packet, right? So our packet arrives. Second. Why does this not show? Oh, second. Sorry, it's tricking me. I need to move this up. Sorry, here we go. Looks better. Okay, good. So, no, that's the wrong one. Let me actually delete this. Sorry, let me just clean this up very quick. Okay, good. So that's better. So again, we have the packet, right? And this now arrives here on the firewall. Okay, so what is now the first information that the firewall can have? Well, the first thing, it comes in on this interface. Okay, and let's just say this interface is, and now I just need to, is Ethernet 1.1, Ethernet 1.2. Okay, good. So now the first information we have is the ingress interface. So let's actually record this down here. Okay, so the ingress interface is Ethernet 1/2. Okay, nice. Good. So what other information do we have? Well, we can see the IP addresses. Okay, so we're going to see the source IP address, which is going to be 192.168.1.20. Okay. And we're going to see the destination IP address as well, okay, which will be 20.3.3.1, okay. Actually, to be fully correct, during the ingress stage, the firewall actually doesn't look yet on the IP addresses, okay, but we have this information. What is actually much more important at this stage is an interface on our next generation firewall is always associated to a zone. Okay, so let's say here we have our office zone. So and then this is actually another information we can now draw from, right? We know it comes in on this interface, and this interface is allocated to the office zone. This means the source zone is now office. Okay, good, perfect. Now at this stage, the firewall does a couple of other checks, like for instance, checking the header and the checksum of the packet, right? And by the way, here we now come already to the first reason why a packet might not, seen in the log. Well, if the packet is, for instance, corrupted and doesn't have a proper checksum, right, then at this ingress stage, it will already be discarded. And these kind of bogus packets, bad packets, and by the way, it is actually something pretty normal in any network, right? That packets are not every packet is perfect, okay? That you have some corruptions of packets because for whatever reason, and then the checksum doesn't match or whatever, it's not a proper packet, right? And then at ingress stage is simply being discarded, and this happens silently, okay? So best example would be, I don't know, you have a 40 cable or stuff like this, then some traffic arrives, but it's not proper, and then it would already be discarded, okay? Good. Okay, so now from here, we're going to move on and we're going to go to what we call our session setup. Well, first of all, actually down here, what we're actually doing here at this very first stage is our network processing. Okay, so as part of the network processing, the packet comes in, ingress stage. Then we have what we call our session setup. Okay, so again, we have our packet right now arriving at the session setup stage. Now, what is the firewall doing here? Of course, when we have, packets always are belonging to a session. So we know which is the traffic that goes out and what is then the returning traffic that is all part of one session. Okay, so and this is important. This means that what the firewall now does here is basically checking, okay, is this already an existing session, right? So for this, what does it do? It look at what we call actually the 5 or 6 tuple, okay? So this is the ingress interface, and this information we already have, okay? It is the source and destination IP address. It is as well the IP protocol, right? So in this case, let's say this is web traffic, so IP protocol would be TCP, okay? And it looks at the source and destination port. So this is web traffic, so let's say the destination port is 80, okay? And the source port, we of course know it's just randomly chosen. So let's just say that is 30,305, okay? Good. So the firewall maybe now does a lookup of the session table, right? And then basically sees, okay, is this kind of an existing session or no? Now, of course, here we know this is the very first packet, so it does not yet belong to an existing session, right? The firewall kind of earmarks it. Okay, for this one, I need to set up a session. What is important, however, is it knows that, well, in a TCP session, like we actually learned here, the very first packet is a TCP SYN. This also means that if the firewall sees things like, okay, a packet arrives and this is SYN ACK, and it has never seen the SYN before, well, it will discard this packet. The other things as well, that actually even attack types where such a SYN packet includes data. Hackers try to do this to kind of thinking, kind of a stupid port-based firewall just allows traffic to go through, or even a next-generation application-based firewall allows the SYN packets to go through, right? And with this, you can in theory tunnel traffic into the payload of a SYN packet, okay? But here the firewall does checks as well, that it checks that it is a proper TCP packet, so integrity of the packet, and the SYN shouldn't include any application data. So if it would also be dropped, okay? So, and and all of these reasons that we now kind of talked about, in all of these cases, a packet is always being dropped, okay? Why? Because we have not yet hit this security policy, okay? So this is a very important thing to remember. Whenever a packet is kind of being dropped before it hits the security policy, we're not going to see this in the logs, right? Because the logs is effectively only once it's evaluated against the security policy, only then it kind of tries to create a session that is then written to the log. Okay, everything happens beforehand will not be examined. Okay, good. So let's move on. Right. So here we had our packet, and we get to session setup. Session setup says, okay, it is a SYN packet, so it's the very first packet. We have not seen any other traffic before, so we go on with our evaluation. So, and the next thing that we want to do now is what we call our slow path. Okay, so what is the slow path? So as part of the slow path, we actually do two things, right? There's a lot of things that happen here, but the most important one by far is actually that we evaluate the routing table, okay? So, and why do we need to do this? Well, of course, we have our packet with a source and destination, right? But in order for us to evaluate the security policy, right? If we look at the security policy, let's actually do this very quick, right? So when we here look at a security policy, what do we have here? We always have things like a source and destination zone, okay? But if we look back here, the destination zone, we actually have not yet determined. We don't know what it is, okay? So, and this is actually what the virtual router will now allow us to do, okay? So this means our packet is now going into slow path, right? And it's called slow path because actually only the very first packet in a session goes to slow path, because only this one we need to proper examine from a routing point of view and do some other things that is part of slow path, okay? So now here what we do is we look up the routing table, okay? In our routing table, we check the destination IP address. We then look at our routes, and let's say we have a default route that points out to this interface here. So let's say here we have a layer 3 interface. Okay, let's say this interface is, oops, give me a second. I need to pick the wrong layer. Let me do this over here. So again, here we have a layer 3. We have a layer 3 interface. Okay, so let's say, of course, this layer 3 interface is part of a zone as well. Okay, let's say the zone, we just call it internet. Okay, so and then based on routing table, our routing table basically says the internet is reachable by default route via this interface. Okay, so and again, based on the interface, we determine what is exactly the zone, right, where we want to send the traffic to, right? So now we know, okay, grant the destination zone is actually internet. Okay, and we know this because our interface, actually I'll put this in here, let's say it's Ethernet 1.1, right? So Ethernet 1.1 is allocated to the internet zone, and we go out there. By the way, there's other elements to the firewall where the zone allocation mechanism is very important as well. NAT is a big topic, right? Once you understand, you know, how the firewall allocates zones based on the interface and the routing table, then a lot of things related to NAT also make much more sense, okay? Good. Okay. So again, in our session, we did our routing lookup, right? So, and now is actually the very first time when we can evaluate our security policy. Actually, no. One information is missing, the app ID, right? Because if we, of course, here look into our policy, right? What do we evaluate? The source zone, source IP we have, the user, of course, the user is part of the mapping of IP to user, right? So that's the firewall does this internally. Device would again be a mapping of the IP to a device. So we would have this information. Then in destination zone, we determine this based on routing table. Destination IP address we have. Device, again, is just a mapping of the IP to a device. And then we evaluate our application and the service to port. Now the port we have, but application we have not yet identified, right? So following the logic, we can't really yet check the security policy. But this would be a problem, right? Because again, even if we, send this packet now to a higher level that is able to identify the application doing the app ID, you cannot identify the application because, of course, right? Remember, we have learned that this packet, it does not include any application data, okay? So if we think this through, it would really mean that we would always have to allow these, let's call them empty application packets, right? The syns and ACK, we always have to leave through to first identify the application to then evaluate the security policy and then decide if we want to allow or block traffic. Now, from a security point of view, this wouldn't be a good thing, would it? Right? Because then things like a SYN flood, even some port scanning, this would always go through because this is all just attacks based on SYNs and ACK, right? So that's not good, okay? So that's why, and that's really important, the firewall always does a pre-check of the security policy. Okay, so yes, at this stage, we are checking our security policy. Okay, so the packet now goes here, and we do evaluate based on these details the security policy. What do we do with the application? The firewall simply ignores it. Okay, so it's very important to realize that the very first packet of a session that goes through, the firewall does an evaluation of your rule base, and it completely ignores this application column. Okay, why is this important? Sometimes you might see that a packet, so let's, for instance, have an example. Let me create a rule. Let me, actually, I can explain it to you on this one. Right? So let's say here we have a rule, and let's say we're actually setting the service to any. Okay, so let's say you have FTP traffic. You know FTP is on port 21, and we do not allow FTP in this rule. But suddenly you have FTP traffic, and then you see in your logs that FTP, this first packet of port 21, was actually allowed by this rule. Well, how can it be if it doesn't allow FTP? Well, it can, because the firewall just evaluates this rule, ignoring completely the applications. And then here, what does it say? Service any. So it basically says from anywhere to anywhere, but from anywhere on the internal network to the extranet, right? Any port, it goes out. Because again, the very first packet is completely ignoring the applications. Okay, so when you kind of troubleshoot and look at some rule hits and wonder why did the rule hit or not, that's actually the reason. Okay, so that's a really important one. Okay, which in turn also means that if at this stage we cannot identify a rule that would allow the traffic, and we block a packet at this stage, then actually this is the reason why an application could come up in the logs as not applicable, because it dropped the packet basically just based on source destination, IP, and port, without evaluating the application, and with this it was not applicable to evaluate the application. Okay, so that's kind of one very important thing here to do. Okay, so now the next stage that we have in our packet processing is what we call, and this is, let's say, the kind of draw it like this with the uppercase, where we do our security processing. Okay, security processing is again where we identify applications and threats. Okay, so as part of our security processing, we have a stage which we call fast path. So fast path, the easiest way to see this one really is see it a little bit as a session manager, kind of, okay? So what really happens as part of fast path is that, let's say here we evaluated, let's say we decided, yeah, we allow the traffic, it goes through fast path, okay? Fast path now sees, okay, listen, this is TCP SYN, doesn't include any application data, you know, there's no point. So of course, as security processing, what else do we do? We do have app ID. All right, with app ID, we don't want to identify the application, okay? And kind of do here our signature match. So, but app ID, we're gonna ignore because no point, right? We cannot identify the application. So, and the other thing that we have is content ID. And content ID, we actually ignore as well, because that's also very important. The firewall will never kind of hit content ID or get a packet to be analyzed as part of content ID, or antivirus, anti-spyware, vulnerability protection, if it did not previously identify an application. Okay, so if it cannot do both of those, it just lets it pass through. Okay, so now, crap, I again was drawing on the wrong layer, but it doesn't matter. I can just draw it on the next one. Okay, because here we kind of need to pass through now anyway. Okay, so fast pass says no point app ID, content ID. We just send the packet now straight out, right? We of course have the information where we send it out and put it in there. Actually, one thing I forgot here, when we are hitting security, kind of our security policy for the first time, and the firewall decides to allow the traffic, this is actually the time when we then identify or create a session, right? So at this stage here, the other very important thing that we do is actually identify a session ID. So let's say here we have, I don't know, session 1005. Okay, so just give it a session ID. Okay, so this happens here. And with this, we can actually also answer the other question we had on our list. How could it be that a session has a session ID 0? Well, if a packet is blocked because it was not applicable at this stage, right? Then there's also no point of creating a session because we're dropping the very first packet anyway, and then the session ID is 0, right? And this we can actually see here in our logs, okay? So remember earlier, I showed you this example of not applicable. So when we now look here into the details of the packet, we can in fact see session is 0, right? So the firewall did not create a session. Instead, it denied the packet right away. Okay. So, and now very important, what this tells us is, okay, a session was not created. The very first packet of the session was already blocked because of the port, or a combination of source and destination IP and destination port, right? Without evaluating the application. Okay. Good. Okay. Now, let's go back. So now let me get this away. Perfect. So now we have the returning traffic. Okay. So what happens now is, of course, the packet came to the server, right? And now the server responds. So that was the SYN, right? Now we're responding back with the SYN-ACK. Okay. And now the same thing just goes backwards, right? Of course, actually one thing I forgot here as well. Here, of course, we have our egress stage. Okay. So once the packet went out, it went out of egress stage. Okay. So, and of course, if now the packet from the server comes back here, of course, this is now ingress, right? And not egress. I'm not going to change this now because otherwise it just messes up the drawing a bit too much, right? But now we have egress, right? The very first thing happens. We have now session setup. Session setup sees, yep, we have an existing session, right? Then it goes to fast path, right? It knows it doesn't have to go to slow path because it's not the first packet, it's the second one. Fast path sees, yep, this is a SYN-ACK. That's fine, right? We're not going to go through app ID and content ID. We're just going to send the packet straight out and go back to the client. Okay, good. So, and what's the last one? Kind of not the last, but nearly, right? So then we have then again a reply from the client, which does exactly the same thing as before, right? Packet comes in, egress stage, identifies the zone, packet goes to the session setup. Session setup says, yep, part of an existing session, gives you the fast pass. Fast pass says no app ID, content ID, because this is just an acknowledgement, and it kind of just sends it out. Okay, good. So now comes the interesting piece. Okay, so now we have three-way handshake established, SYN, ACK, right? Now we're sending the first real application packet, our HTTP GET. Okay, so our HTTP GET now again arrives ingress stage. It goes to the session setup. Okay, session setup says existing session, all good, goes to fast pass. And now is where the logic changes. Now fast pass identifies, yep, existing session. This is now a packet that includes application data. So now we can, in fact, send it to the app ID. Okay, so here now we have our app ID, right, where we do our signature match. Okay, so with this now, the packet goes through the app ID, and app ID now sees HTTP GET, identifies the application, says, okay, this is now web browsing. Okay, so at this stage, we can now identify the application and say, yes, this is web browsing. Okay, perfect. So now comes an important point, okay, that we also need to understand. So here, the next thing that we have is content ID. content ID. Okay, so what is really important to realize now here is that app ID and content ID are very closely related. Okay, one kind of big question that we're always getting in our training is, okay, what is the performance impact when I'm adding more security profiles? Okay, so here we have a rule, right? And in our rule, we can allow our security, kind of add our security profiles. We basically decide what do we want to scan the traffic for, okay? Antivirus, vulnerabilities, anti-spyware, URLs, file blocking, etc. Okay, so the answer to the question, what security profiles to apply, is for all for what you have a license, okay? As a firewall administrator with a Palo Alto Next-Generation Firewall, you do not need to care what it is. So for instance, you could argue that you say, okay, I have DNS traffic. DNS can have vulnerability, so I need to apply a vulnerability profile, okay? But DNS traffic does not transfer data. So with this, it cannot transfer files. And if it cannot transfer files, I don't need antivirus and I don't need file blocking. Okay. Now, the logic would be right, but in practice, if you try to think it like this, it causes you an awful trouble because it gives you way too much prone to error to actually make mistakes of not applying to correct security profiles. Okay. So again, from a security best practice point of view, what you do is you apply all security profiles. Okay. And the important thing now to realize is you do not need to care about the performance because the firewall is clever enough. Because the firewall identifies always first the application. And because it identified the application, it now knows, okay, this particular session is DNS. With this, it's no point of analyzing it with antivirus and file blocking. Okay, but it's important to do vulnerability scanning and to do DNS security on it. Okay, so the firewall, based on the application, knows what type of content ID signatures to apply. Okay, so this is really important, right? That basically the content ID gives over the packet to content ID already tagged, right? So this, we kind of call this as well content ID labeling, right? So the app ID does a labeling of the session, right? Where content ID now knows what security threats to kind of what security checks to apply to. Okay, so and once these are done, kind of goes through it, gives it back to FastPass, and then FastPass kind of sends it out. Okay, so now, of course, I did simplify a lot of things here, right? But again, the main intention, what we really want to achieve here, is show you all of the different elements and also how it kind of all interacts together, right? Now, in the course, we do dive again another level deeper on this, right? To go and see, you know, what happens really with a session, what are the different characteristics of a session, and most important, we're going to go to flow logic, where we can actually also, you know, not only do this on a whiteboard, but really show you in the real thing, right? Actually on the firewall, what happens to the packet, right? So all of these different steps that I showed you here, using what we call debug flow basic, right? You can actually identify exactly at what stage a packet is and where it might have been dropped and why. Okay, so that's, again, is really, really powerful. Okay, good. Okay, so this was the element. Okay, so thank you very much, everyone, for joining. Right, we're going to share the video recording as well, and yeah, hopefully we're going to see you in the next training.
If you like this video, don't forget to subscribe and click on the notification icon to get notified whenever we upload new content.